The title of the paper that I'm going to present to you is OpenGauss, an autonomous database system. The authors of this paper are from Tsinghua University, Beijing, China, and this study is intended for the use of Huawei company. Now, to start with the presentation of this paper, let's start by answering this question. What is OpenGauss? OpenGauss is an open source relational database management system available only for CentOS and OpenEuler. CentOS and OpenEuler are both Linux-based operating system. OpenGauss is not available for Mac, Windows, and other operating systems except for Linux. If you want to know more about OpenEuler, you can check out this website. The goal of this study is to build a self-governing database framework integrated with learned optimizers and database advisor into an open source OpenGauss database system. So the learned optimizer and database advisor are both learned database techniques. Now let's take a look at the components of these learning-based database techniques, such as the learned optimizers and learned advisors. For learned optimizers, we have the query rewrite. Query rewrite is a feature that rewrites SQL query to an equivalent yet more efficient query. The next one is cost or cardinality estimation. This is a feature that estimates the size of the possible returned result set from a given query. The last one is the plan generator. This is a feature that selects a good join order and appropriate physical operators in a query. Now, let's take a look at the second learning-based database technique, which is the database advisor. So the components under the learned advisor are the following: self-monitoring, next is self-diagnosis, and the third one is self-configuration, and the last is self-optimization. Let's start with self-monitoring. Self-monitoring is a feature that monitors database metrics to facilitate other components. So the second one is self-diagnosis. This detects the anomalies and identify the root cause of the anomalies. The third one is self-configuration. These features auto-tunes up the knobs of the database. And the last one is self-optimization, a feature that recommends views and indices. Let's look into the validation method. The validation method used in measuring the improvements in the performance of DB engines after integrating the learned optimizers and database advisor is called the graph embedding based performance prediction. This is used to measure the performance of a DB engine for processing concurrent queries. If you want to know more about query performance prediction, you can check out this website. Let's look what is inside of query rewrite, one of the components of learned optimizers. It aims to transform a slow SQL query into an equivalent one with higher performance. This uses a Monte Carlo tree search based method, or called MCTS, to rewrite a SQL query to an equivalent yet more efficient query. The basic idea is that a policy tree is built. Under selection, you can see that we have a policy tree, where the root node is the original query and the child nodes are the rewritten query from its parent by applying a rewrite rule. Second is the estimation. It estimates the potential benefit of a tree node, an intermediate rewritten query, that may be rewritten further by other rewrite rules. The third one is the update. It enhances the search efficiency, especially when the query has numerous logic operators. This part simplifies the logical operations of the queries. Next is cost estimator. Cost estimator has two layers. The first one is the estimation layer, and the second one is the representation layer. The representation layer is made out of 3 LSTM, or the long short-term memory. The nodes of 3 LSTM inside of the representation layer are propagated by a representation model from bottom to top. And the topmost node is the most optimized estimated model. And this model is sent to the estimation layer to return the cost and cardinality of the query. If you want to know more about LSTM or the long short-term memory, you can check out this website. The third and last component of Learned Optimizer is the plan generator. The plan generator usually enumerates different plans, and these plans consist of joint order selection and physical operation selection. The plan generator usually aims to provide a good order of joint operation, and it uses deep Q network with 3 LSTM to find a plan of a SQL query that is far better than heuristic methods and dynamic programming. If you want to know more about deep Q network, you can check out this website. In this slide, we will discuss the interoperability of database advisor components. So let's start with self-monitoring component. So this component regularly checks the metrics of the database. If it finds some irregularity or anomalies from the metrics of the database, it will notify the self-diagnose component. And this component will identify the root cause of the anomaly and will try to address and fix that particular anomaly by invoking either the self-configuration component to tune up the metrics of the database or the self-optimization component to optimize the view or the indices of the schema. To optimize a view, the self-optimization module will inform the recommender process to generate different views. And from those generated views, a candidate will be selected. And that selected candidate will undergo estimation if the selected candidate has the highest rank among the recommended candidates. After integrating the query rewrite or the query writer into the OpenGauss, it was tested against different database systems. It was tested against PostgreSQL and to some arbitrary database system and to other database system that uses heuristic approach. So there are two different database engine that was used in testing the query writer. The first one is the TPCH and the second one is the GOB. And it turns out that OpenGauss has the most less running time for both TPCH engine and GOB engine. For cost and cardinality estimation, it shows that OpenGauss outperforms other database systems. For plan generator, it was tested against other plan generators, such as those from doctrine query language like the rejoin and DQ. It was also tested in Skinner C that runs MCTS method and as well in QP100 and QP1000 which uses heuristic method. And it turns out that for both DB engines GOB and TPCH, OpenGauss plan generator outperforms other types of plan generator. In summary, OpenGauss has shown significant improvements after the integration of learned optimizers and database advisor. That's the end of this presentation and thank you for listening.